Hey everybody, this is Larry. This is day 14 of the Leetcode Day Challenge. If I could click on the thing, hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's daily problem. I am way tired today, even more than usual. I had 2 days of, for the two of you who likes to hear about my workouts, yesterday was Wednesday here in New York. It is my bench and squat day. And I also, after that, I went to do a speed track workout, like running it on a track. And the day before that, I did 4x4 speed intervals. So all in all, and what that means is that they're very intense, very tiring in general. And I did it in back-to-back days with squats and bench, which I actually only did a warm-up, not warm-up, but definitely not like a full effort set on bench or squat, but because I just got back to New York. But yeah, and then today, knowing that you went on that my body's a little bit tired, I just ran 15 miles. So I am very tired. My body is a little bit exhausted, but that's the way, I think one of the things that I want to kind of, why I'm mentioning this, other than for the two of you who likes to listen to my workout, is that, you have to train for the conditions you want to be better at, right? And for me, I want to be able to grind things out and continue to run, maybe a little bit slower, but even when everything is tired, right? Like, I wouldn't go as far as say like everyone can do whatever when they're fresh, but definitely like if I didn't run for a couple of days, I can definitely run 15 miles, waking up, no preparation easily. But yeah, just 30 miles in 3 days. I'm not in good enough shape to kind of make that easy. But the analogy here, of course, is that on Leetcode, this is the same thing, right? Some days you're going to be good, some days you're going to be bad, and that's the thing with practice. You practice on days where you don't feel so good, so that if you have an interview or if you have a contest or a code force or whatever, and you don't feel that good on that day, well, you have practice. And a lot of it is mental, right? I mean, obviously, because we're solving problems, but not even just like the mental aspect of finding a solution and solving the problem, but the mental aspect of like just grinding and keep going, right? Like you see a problem, you can't figure out in 10 minutes, you have to keep working and in another 10 minutes. And maybe you still can't, and you have to do another 10 minutes and so forth. And at any moment, you could just find yourself giving up. And I see this a lot on my Discord, right? And I'm not trying to, call anyone out, because I do that sometimes too, because it's really hard to focus for so long. But and very often, not all the time, but very often you'll see me go, get back to the contest and come back when you're done. All right, even if you don't finish it, work on it. Figure out the little things that you need to work on. Especially on like Q4, which is a problem that I get a lot. The reason why people don't solve Q4, I mean, there are a lot of different reasons, of course, but one of the reasons is that Q4 has like 3 or 4 things you have to notice and things that you have to figure out, right? If you don't practice having that focus of being able to solve something in an hour, right, then it's just very hard to summon it when you need it, right? Yeah. And I think that also is one of those things that I mean, I didn't bring this up in my other video of when to move on, but also because at that time I wasn't training for an ultra marathon. But I think that is a thing, right? Is that, I mean, the idea is kind of similar in that every step of the way, it's so easy to give up because it doesn't matter in some sense, right? It doesn't matter, so you could give up and just take a nap or whatever, right? But that's the thing, right? If you practice your focus and your grind when things don't matter, it's so that when things do matter, you're prepared, right? I mean, I also say that in similar way for like anxiety and stuff as well, right? Because sometimes if you don't make yourself uncomfortable, and during an interview, maybe you find yourself very uncomfortable, and then you just blank out and you just can't go on, right? So you have to practice these conditions, you have to practice these things, and that is part of deliberate practice, is having that fortitude of, okay, I mean, not everyone's going to be able to solve something in 10 minutes, right? Because if you did, then, well, maybe you're not watching this video in any case, except for Gia for some reason. But he's also been getting very good, so props to you, a shout out. And then he's also good, but yeah, whatever. Okay, a couple of shout outs, but you get my point, right? Which is that, you know, and hopefully I'm leaning by examples a little bit. I mean, both in the running and today, I ran 15 miles, to be honest. After 5 miles, which is an hour in, I was like, why am I doing this? Every step of the way. And I had to grind another 10 miles of, oh my God. I don't even know. It's a weird feeling of fatigue. Like I was just so tired the last 10 miles. It wasn't even like my legs are fine. I don't feel sore or anything, but it's just a different, like a sort of, it's all mental is my point, right? And it's the same thing with these hard problems, right? You have to go through like 3 or 4 or 5 different observation and gates, and you know, maybe you're able to do three of them, but you still have 2 more, and you know, you have to be able to grind it out. You have to focus. You have to kind of play with different things, and you have to play with different ideas. Yeah, and of course, and that's, I mean, that's a little bit of a higher level thing, right? Because, of course, this assumes that you have all the knowledge and you have all the basic and, you know, all these things that you're also practicing on, right? So, yeah. All right. It ended up being a longer intro than I expected, but hopefully this is something that makes sense. And this is why, you know, the really good people are really good, right? They make it seem easy, but all the practice that they do is usually not. All right, let's take a look at today's problem. 945, minimum increment to make array unique. You're given an integer array nums. In one move, you can pick an index I where 0 less than or equal to I is less than num sub length, and increment num sub I by 1. Okay, so we can increment minimum number of moves to make every value in nums unique. Okay, I mean, I think this is the same as yesterday, right? I mean, obviously not exactly the same. I guess that's not always an obvious with Leetcode, because, you know, Leetcode sometimes just give you exactly the same thing. But okay, so yeah, so the first thing that you want to do is just, I mean, okay. So I think in a greedy way, let me step back for a second. In a greedy way, there are no decisions, right? The base case of, if every number is unique, then you're already done. But what happens if there are 2 numbers that are the same? Well, there are also no decisions, because they're the same, they're fungible, and by fungible I mean like it doesn't matter. You know, there's no differentiating thing between the 2 numbers that are the same. So you could add, so they're, what is the word? I mean, I said fungible is a very precise word, but I also think it's not quite understandable. But it's not differentiable, right? They're just the same. So if you increment one of them, it doesn't matter which one you increment. And in that sense, there's no decision, because you have to increment one of them so that it has a chance to be unique. It might not be unique, or the array may not still be good, but you have to increment it to give it a chance, right? And then it's kind of almost, it's not an induction per se, but you could kind of imagine that idea and then just keep on going and incrementing as you necessary. And every step of the way, there are no decisions, right? If there are 2 numbers that are the same, increment one of them. Keep on doing it until you're done, right? So in that way, that's the idea, right? Of course, the tricky thing about this problem is that how do you do that, right? How do you do that in an efficient way? Because you can do what I said probably in n squared time or something like this, maybe even longer. But like if you just write a while true loop, do a for loop to see if everything's unique, and then increment, I don't know, to any number, right? So you could definitely do that. Maybe it's n squared, maybe it's worse, I don't know. So you want to do it in a way that is fast. And of course, in this one, I guess we're having a sorting week, which makes it a little bit whatever. But is just sorting it so that you have a structure to work with. And there are other ways to do it. I think yesterday's problem I just sort because it's easy, but you can do in some sense a counting sort, if you will, but you by linear sort, because you could just look at the constraints. But I don't know. I do it if I need to, but in general, I don't know. Maybe just not something that I prefer. So as I was saying, I'm so dead tired, and part of that being dead tired is not enough hydration. So I'm drinking a lot of water, which is good for me. So. But yeah, so that's basically the idea. So here we can do a numsat sort, right, to give it a structure. And the way that we can do it is just to take advantage of a property of sorting, I guess. I don't know if it's a property of sorting. Maybe that's a weird way of phrasing it. But it's just a property of the array after a sorted array is that if there are two numbers that are the same, they're next to each other, right? So we can kind of just use that and exploit that. So let's do it. So now for right. Why did I write that? So I've had that as a bug before, and I had to debug it. I don't know why I do that though. But yeah, so then now if num sub I is equal to num sub I plus 1, then we just increment num sub I plus 1, right? Alright, let's just say what's it? Count is 0 0. Oops. And what happens here, right? Here, after this, so here, let's just say you add a statement here. So then now, the thing that I always talk about is loop invariance. And then now after this, then it is true that num sub I is obviously not equal to num sub I plus 1, right? Maybe I'm being a little bit sloppy on this actually, because I think there's a case where, I mean, that is definitely true, but then I think I'm missing the case where it's like, also I think this is not great. I think I didn't really analyze the bounds enough, because I think so let me step back for a second and rethink this. I think I'm really tired, so I'm practicing doing problems tired, put it that way. But like, for example, if you have like 1 1 1 1 1 and you have like 10 to the 5th of them, the way that I'm doing it, even in an effective way, which I don't think I am doing now, this becomes 2, and then let's say this becomes 2 but then now this becomes 3 ... right? And then now 4 4 4. But if you practice, then you'll see that this is a pattern of, roughly speaking, n plus n minus 1 plus n minus 2 ... which is n squared. So definitely, I actually didn't expect, for some reason, I don't know, maybe I just missed the n in my head. I mean, I looked at it, but I think I just didn't actually process it. But yeah, this is going to be n squared, right? So anything that you do where you do a count plus you go to one at a time is just going to be too long, just by definition, right? Yeah, I mean, so we have to do something a little bit more cleverer. Yeah. So guys, so then maybe the opposite case is that if this is the case, right? What does that mean? Then this is equal to nums of I plus 1, right? And then count, we have to do the delta maybe. So then delta is equal to nums of I minus nums of I plus 1, right? So then this is going to be delta plus 1 because, yeah, and then now this is plus delta plus 1, right? And the reason why this works is that after sorting, now you assume that everything is in order, right? And that means that if the number, let's say 2, 3, and then 1 more. If the number before you increment 3 times, that means that it just assumes that all the numbers before 3 are taken. Because in it's not pigeonhole, but basically the only way that this number is smaller than this number is just that all the numbers that are smaller than 3 are taken because you always sort it premature. Or maybe another way of saying is that we know that this number used to be, I'm just looking at the 3 and the 1, right? Here in this index. Another way to think about it is that this number 3 used to be, because we sorted to begin with, this number 3 used to be either smaller than or greater than 1. But that means that we increment this number to be greater than 1 because every number from, at the very least, 1 to 3 are taken. So then because of that, then you have to take the next number, which for this is going to be 4. And the same logic applies and then so forth. So that's how you get this idea. And of course, now that you do it this way, this is just going to be O of n. This part is O of n, of course. This is still n log n. Did I make a mistake? I mean, I clearly did, but 1, 1, 2, 2. Why am I outputting? Oh no, I'm outputting 2, not 6. I always forget what order they have it in, so I'm like, why am I outputting 6? Because that's just wrong in a way that I don't understand. But yeah, okay. Oh, why did I do? Whoops. Typo. Well, no, it's because I had it as nums plus 1 before. Okay. Huh, I haven't done this one before, apparently. That's kind of, I mean, it's nice to see a new problem, I guess. But yeah, this is going to be n log n because of the sorting, and then you have this for loop. This is actually a very weird relationship to come up with, I'm not going to lie. Because of this, so I think if I want to put in loop invariant, before I said that after this if statement, this is true. But then now another thing is true, right? Is that so now is equal to this, but also so these are the invariants, right? Oh, this has to be greater than strictly, of course. But another invariant is that all numbers from nums of I to nums of I plus 1. Well, this is actually always going to be just equal to this plus 1. Well, not always. Okay, sorry, I take it back. If this statement happens, then of course it's going to be plus 1. But this means that are used, right? So that's basically the loop invariant. Yeah. And that allows you to kind of look at the next number in that way. It's a very weird relationship. I don't think I'm explaining that well, but I just kind of, I don't know. Yeah. Anyway, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.